You need at least a sheet of notebook paper. This is going to be the majority of the grade. It's going to count at least 2 quiz grades. But it needs to be organized really well, just so I can see where everything is. But if you do that, then they should be really easy to grade. So we're going to go through these problems one at a time, but not in order. We're going in order from most missed to least missed. So, for example, the first problem we go over is going to be number 34. So on your notebook paper over here, it should be very obvious that the first problem we are going to do is 34. Some problems you're going to have a lot of work for. Some problems there's not going to be as much work. But it needs to be very easy and very clear between where problems start and stop. To be honest, the easier that is, the easier I'm going to grade. So like we're going to have whatever work we have for 34, and then you're going to have a line drawn, and then you're going to start the next problem and so forth. It should be easy enough to where I can go through and count like this, and count in the order of the problems and be easy to grade, easy to differentiate. But so this is going to count as at least 2 quiz grades. You need to be writing stuff, which means not being on phones. So phones should be up. Also, I'm using this as a reference, but that doesn't mean we're only going over the problems exactly how they are. If you have a question that has something to do with this problem, just stop me there, we'll go over it. If you all of a sudden think of something completely off topic that has nothing to do with the problem and you want to talk about it there, just stop me and we'll talk about it. We got through 15 problems all class period in my last class, which is probably about what I expected to get through. So I don't mind taking a lot of time on this. My other thing is I am choosing to go most missed to least missed. So know that ahead of time. Don't leave here feeling very defeated that of the ones I went over, you didn't get many right. I'm going over the hard ones first. And I forget to say that sometimes and people walk away kind of deflated from that. Another thing that I'll probably do is on the half sheet with your answers as we go over them, mark if you got it right or wrong, because I haven't given you anything that says if you got any right or wrong yet. Alright, so we're starting with 34. So on your notebook paper, go ahead and write 34 right here. And then go ahead and flip in your pages to problem 34. Also, I am not going, when I go through and grade your work, I'm not grading anything on this piece of paper, the one that you have as your printout. I don't care if you mark on it, but I'm not going to sit there and scan through all of this in addition to your notebook paper. I'm only grading your notebook paper. Okay, a researcher has conducted a survey using a simple random sample of 50 registered voters to create a confidence interval to estimate the proportion of registered voters favoring the election of a certain candidate for mayor. Assume the sample proportion does not change. We're sampling from the same group essentially. Which of the following best describes the anticipated effect on the width of the confidence interval? So that's the whole question right there, is how does the width change? If the researcher were to survey a random sample of 200 instead of 50. So now we're going to have n equals 200 instead of n equals 50. So what happened? What did I change?
Sample size.
What did I do to the sample size?
Increase it 4 times.
There should be one thing that you could say definitely immediately when I say sample size increases. As sample size increases, what the problem is asking?
Confidence level decreases.
The width does what?
Decrease.
This is something you definitely need to know. So at that point, I've got my new versus my old. So 1/4 smaller, 1/2 smaller, the same, twice, that's bigger. 4 times, that's bigger. Just from this one statement, you should be able to knock it down to between A and B. In every equation, the sample size is like in what part of the equation? It's a strange question to ask. Like I'm writing it out, I will always find the sample size in the
The question.
denominator, and it's always in a what? Square root. So I've got something over square root n. So one of them I've got it over square root 50. One of them I've got it over square root 200. Some people are gonna like make up a number, put like 1 here and 1 here, and then just see how much it changes. You already said 200 is what in relation to 50? 4 times bigger. So I'm taking this value, 4 times that. Well, what's the square root of 4?
2.
So what's the right answer here?
B.
But some people are actually going to like make up a number and type in 1 divided by square root 50 and see what it is, and 1 divided by square root 200 and see what it is, and then find out if that was a fourth of it or half of it, and that's fine too. So you should be writing stuff on your notebook paper to go along with what we're saying. And in all honesty, the more you write, the less likely I am to go and critique it. If you're not writing much, I'm probably going to go back and make sure there's not more stuff you should be writing. And if at any point I go too quick and you want me to slow down, or you're writing something and I change the screen, just yell at me and tell me to stop. The time is not of my concern right now. All right, now we're going to number 22. So on your notebook paper, all of your work for 34, draw a line, make it very clear that we're now switching to number 22 and so forth. This one is a difficult problem. I'm going to go through, well, relatively. I'm going to go through the whole thing the way you should have done it, and then go backwards and see how you could have actually done this problem and never done any work. And so a game of chance is played in which X, the number of points scored in a game, has a distribution shown above. So if I play a game once, what are my possible options for number of points I could get? 0, 1, or 2. Probability of getting 0 points is 0.3. Probability of 1 point is 0.4, and so forth. Which of the following is true for the sampling distribution of Y, which is the sum when I play the game twice? So I'm going to start this problem the way you should have done this problem, and then go backwards from there. And I don't know that everybody would think to do exactly what it is that I'm doing. So I played the game once. What are my possible options for points I could get?
0, 1, 2.
What is the probability that I got 0 points? Look at the chart.
0.3.
0.3 was probability that I got 1 point,
0.4.
and then 0.3. Alright, I played the game a second time. If I had 0 points, does that change my options for my second game points?
No.
No, so all of those, I could again get 0, 1, or 2 points. And with 0.3, 0.4, 0.3 at each of those. But it's concerned with the what is Y? The what points that I got?
Sum of the
The
scores.
sum of the points. So on my first path over here, What's the total amount of points that I could have had on my first path?
0.
0. On my next path, it would be 1, and then 2, and then so 1 and 0, 1, 2, 3, 2, 3, 4. So that's just my sum of points, like that's my y. How do I figure out the probability of this first path?
Multiply.
So I'm multiplying this path right here. So 0.3 times 0.3 gives me 0.09. My second path would be 0.3 times 0.4, which is 0.12. So I'm just multiplying my paths. Most of these are pretty easy numbers to multiply and repetitive. So my actual distribution here, my number of points I can have is 0, 1, 2, 3, or 4. How many paths ended up with 0 points?
1.
So the probability of that is just that one number. What would I do for the probability of 1 point? So my rules that I always say is you what down, multiply down, and add across. So these two paths would be added to get 0.24, and then adding up is 0.34, 0.24. There's only one path with 0.09. So that's the way this problem should have technically been done. But that's a lot of work, and I think a lot of people just didn't think to go that direction. And so once everybody writes that down, then I'm going to back up and show you how you could have just thought through this problem without doing that and still gotten the right answer. And I'm thinking some people just didn't play the game twice. And some of these that were the most missed were ones that like this is usually typically the most missed problem. But some of them are of more concern than others, like the thing that you missed. Anybody not okay if I go ahead and erase this up here? Just gotta move it over. Alright, so I play the game twice. My possible points each game are 0, 1, and 2, which means I can immediately think, what are my possible options for number of points I could have? What's the least amount of points I could have?
0.
What's the most?
4.
Or could I have 1 and 3 in there?
Yeah.
So that should immediately knock out these 3 right here to understand what your options are. At that point, we're just looking at D and E. Now, if I graph this, because you see that your probabilities are 0.09, 0.24, and 0.34, it's going to look something like, not drawn very well or to scale, but like this, with this being 2. Is 2 the mean? So that looks fine. If I didn't go as far as we did to get these probabilities, what's the other thing that D says?
Binomial distribution.
What does binomial distribution mean?
Even.
To what? What? 2 possible
Answers.
outcomes or answers. Is anything in this process only 2 possible outcomes?
No.
So you could have gotten to the correct answer without going through the process we did if you kind of thought through it. But like I said, I think that one's, I get why people didn't
But
necessarily.
how can you automatically just mark out A, B, and C?
Because if I can get 0, 1, or 2 points on the first game and 0, 1, or 2 points on the first game, it is possible for me to get any of the points 0 through 4.
Wouldn't it be better to do the question the way we just did because
Yes,
it
yeah,
saves
yeah.
time?
So like a lot of them I'm gonna answer it like the correct way, and I'm gonna answer it like if you didn't get to that, you should be able to think through pieces of it, kind of. Yeah, but yes, you're right. We should have done it the correct way. Alright, number 30. Now this one is again often a most missed problem. The problem itself is actually very easy, but the wording to get to what the question is asking is difficult. A delivery service places packages into large containers before flying them across the country. These filled containers vary greatly in their weight. Suppose the delivery service's airplanes always transport 2 such containers on a flight. The 2 containers are chosen so that their combined weight is close to but does not exceed a specified weight limit. So this is saying we've got some container A, we've got some container B, and we want them to get really close to, but not above the max. So anytime I add the 2 containers, they should be getting close to whatever that max is. So let's just kind of make up a number here, do something easy. Let's say we're going to add 2 numbers to get to 1. What are 2 numbers that I can add to get to 1?
0 and 1.
0, 1. Give me, or 0.5, 0.5. Give me something else.
0.7, 0.3.
Alright, so let's now look at this. As my A numbers get bigger, so I go from 0 to 0.4 to 0.5 to 0.7, what happens to my numbers in B?
Smaller.
Which means what?
They have a negative correlation.
As one gets bigger, the other one gets smaller. That is a negative correlation. The problem itself is easy. Getting to what the problem is actually trying to tell you is confusing.
Wait, as A gets smaller.
If I put more weight in B, that means I have less weight left for B. Or if I have more weight in A, that means I have less weight left for B.
Okay. How I couldn't figure out what this question is asking.
That's the hardest part of this one, is I think the wording. And so the only difference is if it were like as A decreases, B decreases, then that would be what? If they do the same thing, regardless of which direction they go, it would be what? Positive, and we would have to know more about which the answer would be. Number 33.
Can you go back to a second? I want to finish it. Please.
Oh, and I am recording, and I'm gonna record everything. So if you get to a point where like you know you're just listening to me and you're not writing something down, and you just want to jot down really quick like what time it is, so you can go back and look at the video and not have to search through the whole thing. That's also not a bad idea. All right, so number 33. An independent research firm conducted a study of 100 randomly selected children who are participating in a program advertised to improve mathematics skills. The results showed no statistically significant improvement using alpha equals 0.05. The program sponsors complained that the study had insufficient statistical power. That sentence is good, correct, but it's not the way we usually talk about things. Assuming that the program is effective, so assuming that we basically should overturn it, have evidence of it, which of the following would be an appropriate method for increasing power? So basically, out of this entire problem, that's all you need to know is which one would increase power. Now I'm going to go way sidetracked to answer this question because I want to talk about one of the wrong answers to get there. What do we usually associate 3 things? Power, what, and what?
Alpha, beta.
Power, alpha, beta. So when we go back to this thing, what do I usually put here? No hypothesis is true. This one is what?
H.
Or HA true. What are my two options here?
Alpha and something.
Before that.
True.
If it's this, I have a decision to either what or what.
Oh.
Reject or fail to reject.
And that's regardless of which actually was. So then we have names for the different paths. If my null hypothesis is true, but I rejected it, we call that a what?
Alpha. Type 1.
This second one we don't have a name for. This third one, I call it it's kind of like the what? It's not technically a name for it.
Ideal or
What?
was it ideal?
Yeah, like this is like the ideal one if you want to write that. Like that's the whole reason we did the test is we think that's what we want to prove. And then this last one is what?
Type 2.
Alright, so now I have to associate things with it. The probability of each one. What is the probability of a type 1? Symbol, Greek letter.
Oh, alpha.
I don't have anything for my second path. What is it called for my probability of the ideal one?
Power.
And what's the probability of my last one?
Beta.
Alright, so associating this again, power and beta are on this same piece over here, which means as one goes up, the other one what?
Goes down.
Goes down. So power and beta have what kind of relationship? And yes, what you said, I usually say it this way, indirect, which is negative correlation. As one goes up, the other one goes down. What about alpha and beta because they're both different errors? Directly related or indirectly related? Indirectly, which again is negative correlation. As one goes up, the other one goes down. Which means by default, if power and beta are indirectly related or inversely related, alpha and beta are inversely related, that means power and alpha what?
Directly related.
As one goes up, the other one goes up, or as one goes down, the other one goes down. So we are trying to increase power. What's the only answer choice that talks about alpha? And what that one says we're going to do what to alpha? Decrease. So is that correct?
No.
And that's one of the main reasons I wanted to. This is a good problem to discuss all of this with. But a lot of people pick that answer, and that's your justification there. Now, if you can most people are going to answer this question in about 30 seconds or 10 seconds if they know the right answer. What is the best way to, if you're increasing power, you're making your results better, what's the easiest way to increase power? Increase your sample size. And that's always something that you can do. Okay, so you should have 4 problems written on your notebook paper. This is the 5th one, which is number 21. Now this is one that I was kind of genuinely concerned about because it's something that you should definitely know. Or there's one answer that people are choosing that should definitely be known. The other one I get a lot of people get confused. Alright, so an experiment has 3 mutually exclusive outcomes. If I'm talking about different outcomes and I draw a box, what does that box represent?
Population.
The entire population, the entire sample space, all the possible outcomes. So if there are 3 that are mutually exclusive, visually, how do I put that here?
3 bubbles that are not touching each other.
That are not touching each other at all. And there can still be things that aren't A, B, or C that are in that sample space. And we've got different numbers to go with them. So when I say that the bubbles are separate, that means they do not what? Yes, but more so. Overlap. What does this word mean as far as that picture?
If it has both properties.
So it would be where they what? Overlap.
Then eliminate that.
So do A and B overlap?
No.
So should probability of A and B be equal to 0?
No.
Well, yes.
If they don't overlap, that means the overlap shouldn't be there. And that's the one that's my main concern that I saw missed a lot, is people not going with that answer. Now, usually we associate and with multiplying, independent, dependent. We associate or with adding, subtracting, and mutually exclusive, not mutually exclusive. Just because it's a good place to discuss this. And again, if you have questions at any point, just stop me and I can talk about other things too. If I'm writing this equation, what's going to go at the end?
B and C.
So I have 2 equations that are saying the same thing. So just as a review, when do I use the top one?
And they're mutually exclusive.
And when do I use the bottom one?
Not mutually exclusive.
Are B and C mutually exclusive?
Yes.
Yes. So is C correct?
Yes.
Yes. And most people chose that one as correct in their answer. So the only thing we have left is to decide about independent. And this is the one where I understand, especially coming off break, and I told you don't look up, you don't need to review anything or look up anything, that some people just forgot what to do there. Alright, so how do we tell if B, no, A and C are independent? So if I want to know if 2 events are independent, I check to see if what?
Their
A and C
probabilities
equals
add up
0.
to 100.
Something given something, but I don't.
So where does A go? The given, or before the given, or after the given? Is A what's given, or is A what we're finding probability of?
A is what we're
given.
finding probability.
We still want to find the probability of the same thing. We're just throwing in a second given. So the problem gives us this. What's the probability of A? So this, what thing is given?
Probability and probability C.
Reading this visually, what is given?
C.
C. So given that I am in this circle, what is the probability that I'm in?
0.
Are those equal?
No.
So are A and C independent?
No.
And so I get why if people miss the problem just because of number 1, 2 is more of my concern because that's an easy one that I want to make sure that we're good on. So the correct answer here should be D. Number 12. This is one that only certain answer choices are a little bit concerning. I think some people might have missed this one because they didn't read the problem. And then there's one main concept that they're testing for here. So we have a random variable x that is normally distributed with a mean of 10, standard deviation of 3. And then separately, we have a random variable y that is normally distributed with a mean of 9, standard deviation of 4. X and y are independent. Which of the following describes y minus x? There's one thing that the problem set you up for that if you're not paying attention, you're going to do wrong. Like an easy, it's trying to trick you.
Y minus X.
It's y minus x, but it gave you x and then y, so you've got to make sure you're paying attention to that. So, what is my rule? Not a rule. How do means always work?
Why you think they would?
Exactly what you would think they would. So if I'm doing y minus x, then what do I do to find the mean of y minus x?
9 minus X.
Which will give me,
-1.
and if you're not paying attention to the order, you could go with A or D there. Now, this is the main thing the problem's actually testing. Once you get past those little things. There are always how many rules when we combine standard deviations? 2. What is one of them?
Always add.
And what's the other one?
Square them.
Square them or combine as variance. So when I'm taking this, I have to make them as variance. So sigma of y squared plus sigma of x squared. But I want my answer as a standard deviation, so I have to what?
Square root.
So what is my variance for y?
4. Or 16.
What is my variance for x?
9.
So I'm taking 4 squared, 3 squared, What's 16 plus 9?
25.
Which gives me a standard deviation
5.
of 5. If I put two standard deviations together, are they ever going to get smaller?
No.
So I have a standard deviation 3 and a standard deviation 4. If I put those two together, I can't get smaller. So even if you couldn't remember the rules, and you could remember, you could do 9 minus 10, and remember that part, you're down to 2 answers. With the answers C. So combining standard deviations, you always add combined with variance. Means always work exactly the way you think they would. At 27.
We have to turn this paper into the class before we go back and watch the video.
You can watch video, and it'll take us at least 2 class periods to get through this whole thing. I said 27, and this is our 7th problem. Alright, so this first part is seemingly insignificant to you guys, and you could have done it without it, but I want to explain to you what that means later. Histograms below represent the distribution of 5 different data sets, each containing 28 integers from 1 through 7 inclusive. I only want to explain to you what that means because they like to use this type of thing a lot on the AP exam, and sometimes if you get stuck, you can use that to help you. It means our options are 1 through 7, like this, for all of them. And you can kind of think through this as, like, I can see where I could draw these lines across if I wanted to. So how many 1s are there? How many 2s are there in this in B? There are 3, 3. Do you see what I'm talking about? And I can do this for every problem. So I have 7, 7, so forth. So this gives me 8, 16, 24, 25, 26, 27, 28. There are 28 boxes here. That's what that means. And eventually I'm going to show you how you could use that to answer the problem too. Alright, so now let's actually look through this problem. So let's start with C and D. The middle of C and D are very clear and very obvious. Why? The means of C and D are very obvious because of what?
Symmetry.
They're symmetrical. Put phones up or I'm giving zeros. So we are concerned with standard deviation. So standard deviation is what? If I had a written definition of standard deviation, it would be what? So I want to know how much each thing contributes and how much I have contributing that much. So in C, I have a whole bunch on my mean line, which means how much are those contributing to to the distance? How far are these away from the mean? 0. Are there a lot or a few of them? There's a bunch of them. Whereas here, I don't have very many that are contributing 0. Here, I have few that are contributing the most. Here I have a lot that are contributing the most. Does that make sense? So between C and D, which one is going to have a higher average distance from the mean? D, right? I've got a lot contributing 3 away, whereas here I have a lot contributing a 0. So these are going to add up these are going to add up to bigger than these are. What about versus E? So like if I had to put the largest to smallest standard deviation of C through E, which one would be the largest?
None.
Which one would be the largest standard deviation, C through E? Which one has the smallest? C. And E is somewhere in between. So here I've got a whole bunch of zeros and not many threes each direction. Here I have a whole bunch of threes and not many zeros. Here I've got some threes but some zeros, so that's going to be somewhere in between. Now looking at A and B is a little bit less direct than C and D. The middle of these numbers is here, but I've got more on that side than this side, so it'd be kind of pulling it, the mean's probably closer to like here. Same thing here. This is the middle, that's pulling it maybe about here-ish. So this one is definitely 3 away for each of those. Does that make sense? But here, this is going to be a little bit less than 3 away. You'll see why I'm doing that, because it got pulled farther that way. Here is going to be a little bit more than 3 away, but how much does it contribute? Not much. More than 3 away, but doesn't contribute much. So are these going to be more or less than this one? Less. So we've already decided that this is the obvious of the bottom. We can kind of compare that these are still going to be less than that standard deviation.
What should we write for this case?
I don't know. I'm not very picky about that because I might tell you to write one thing and it might be like perfect sense to one person and somebody else is like, if I wrote that down, it wouldn't mean anything to me. So this is to help you. But I do want to show you a very long method, but possible method, just so that you can get perspective of a different way to do these problems. So with A, if I drew the lines in, because it'll draw it to scale like this with these problems. So it looks like I have 1 7, 2 6s, 3 5s, 5 4s, 4 3s, and so forth, right? So if I wanted to do this, if I all of a sudden got to the end of the test, this is one of the only problems I had left, and I have time, I could why does it never want to work in this class? Okay, just take my word for it. In a list, I literally in list 1 typed 1 1 1 1 1 7 times, then 2 2 2 2 2 6 times. I typed the number 3 4 times, and so forth. And then I want to know the what of that entire list. So I can go to one variable stat and figure out what the standard deviation of that list is. So like if I'm down to, I can't tell the difference between A and D, I could go and type that in and figure out which one had a higher one. Does that make sense? Now, in no way would I encourage you to, when you're going through the test, choose to do it that way. But if you get stuck on a problem, this concept might be useful if you're like between two and you have extra time, because they draw graphs like this a lot. So that's just kind of a different way to go about things that would technically work. All right, 18. Now, this one I do think is difficult because there's so many tiny pieces that you kind of have to think through to get there. So a t-statistic was used to conduct a test of the null hypothesis of mu equals 0 against the alternative mu does not equal 0. So what kind of test is this?
Two-sided.
Two-sided. So the p-value was 0.056. A two-sided confidence interval was to be constructed of the following, which is the largest level of confidence for which the confidence interval will not contain 0. First important thing is, why does this number say 0? Where did that come from? The what?
The null hypothesis.
So it's not always 0, it's does the number we're testing fall there or not? If I'm looking at it like this, here is my confidence interval, here is not my confidence interval. So if I wanted to visually draw this, where would I draw a line?
On one of the peaks.
In one of the shaded areas, regardless of which one it is. Everybody go with that connection? If I were running a test and I ended up getting a result of my line here, what does that mean in my test? I would make the decision to what? Reject. And like I said, there's a lot of pieces in this problem. This is a hard one. When do we reject?
When the p-value is less than alpha.
Now I've got to erase what I put up here because I'm in my way. Alright, so our p-value is 0.056 for all of these. A 90% confidence would be between here and here being 90. So what would that leave as my alpha?
0.1.
If it's 93% confidence, that would leave what?
0.07.
Just whatever's left over. In this first scenario, my p-value is what? My alpha. In my second one, my p-value is what? In my third one, my p-value is,
Great.
and the way I just said, not less than, not less than, not less than. So we've already decided that we are rejecting. Which of these rejects?
Both A and B.
So both of these reject. Which is the largest confidence level that rejects?
B.
So there are a lot of pieces to that one problem as far as a thought process. And I get why that one is missed a lot. But you should be able to, even if you would have gone nowhere close to what I just did, you should be able to follow and understand what it is that I just showed you. Number 16. And now this one is a very straightforward one. Either you knew what you couldn't do, or you didn't. So I've got two different samples. For each sample, I have a sample size, a mean, and a median. And I want to know about putting them together. The easiest way to always think about this concept-wise is I always think about money. So let's say we're talking about money. Do I have an equation? What is my equation to find mean? Like before this class, if I said, how do you find mean, you would tell me what?
All the numbers divided by the amount of numbers.
How do I find median?
The middle number or
All the number, how many numbers there are? Plus 1 divided by 2, and that just tells you where it is. That doesn't actually tell you what the number is. So I have an equation for mean. I do not have an actual equation for median. So if I wanted to put these together, sample 1, each student has an average of $42.6, and there are 21 of them. Can I figure out how much money that class has?
yes.
By doing what? Multiplying 21 times 42.6. And then how would I figure out how much sample 2 has?
46 times 49.2.
And then now if I want to say, okay, now we're going to all put it together and then split it between each of us, I would divide this by what? How many people would there be now? So this is the correct way to find the combined mean. I had an equation. I could undo my equation, put it together, and then redo my equation. I do not have an equation for median. So if all I have is the middle number, and I know how many there were, can I now find my new middle number? Yes or no? Do I have an equation for median? You cannot find combined median without actual data. And this is a concept that shows up relatively often. So my answer to this question is what? E, because it asks about the median of combined. And that should have been the 9th problem. We're on the 10th now. And this is problem number 13. The concerning part about this one is that this is the second time this one concept has come up, which should be a concept that you know, and it's appeared twice in the first 10 problems with most missed. So the graphic sampling distributions 1 and 2 are of the sampling of the same random variable. So I'm taking it from the same group. But the only thing that is different is the different sizes. So when I am looking at these, visually in this graph, what can you tell me about the distribution of 1 versus the distribution of 2? There are 2 words I can put here. Like just look, not even my class, just looking at it.
Taller,
And what's the other one?
thinner,
Which one of those do we relate with changing size? The width. So if we are talking about the width as your sample size, again, the second time we've had this same concept, as sample size increases, what?
Distribution with decreases.
So if 1 is narrower, then is what?
No, like the population or the sample size.
So this one is narrower, a width is smaller, which means that sample size is
Larger.
so that's the second time just this concept right here showed up in the first 2 problems. So I get some people might have read A or B wrong or something, but the sample size is not equal. That's the only thing we changed, and the distributions are different. Again, it's not that it doesn't affect it, it's the only thing we changed and they look different. And yes, we can compare them. So these are the ones that should be an immediate no. And I had like almost 45% of students picking between D and E. That's the thing for me. At 23. This is one that I get why people mix this one up. Julie generates a sample of 20 random integers between 0 and 9 inclusive. So if I am generating integers between 0 and 9 inclusive, how many options do I have? 10. She records the number of 6s. So 6s are what I am deeming as my what? So 6s are my success. I have 10 options to choose from. I can go ahead and skip down here and look. Well, something's talking about P. Well, P is probability of success. So what is the probability of getting a 6 if I have 0 to 9 to choose from?
1/10.
So I can already knock out A and E at that point. Now, what looks like the biggest difference between B, C, and D is sampling distribution versus binomial distribution, which actually isn't much of a difference. What's the other thing?
The sample size.
The sample size. So when way back when, we did coin flips, and you did 20 coin flips, and you put a sticker on the board for where your 20 coin flips landed, right? Did you need to know that you flipped that coin 20 times to be able to put your sticker up there? Was it important that I told you you had to flip the coin 20 times? If somebody else flipped it 1,000 times, would that change where their dot might be?
Yeah.
So that was important that you flipped it 20 times, right? Did it matter how many other people put dots up there? Did that change anything that was going on with you?
No.
So this 100 is how many dots go up there. As there are more dots, it might look a little bit better, but we're repeating the process of doing it, each coin flip being 20 times. So this is the one that is the correct answer. The 100 is just how many dots are up there. And I get why that's confusing, and I get why the sampling distribution versus binomial part throws you off.
So the 100 comes from the person doing 99 plus 1.
Mm-hmm, mm-hmm. And so with this one, I get why people get confused between B, C, and D, but I need you to be really good with why it's not A and E. At 32. There's a lot of wording in here that most of you probably aren't even going to pay attention to or realize that you needed. I'll talk about that at the end. Consider a data set of positive values, at least 2 of which are not equal. Which of the following sample statistics will be changed when each value in this data set is multiplied by a constant whose absolute value is greater than 1? So I am taking every value and multiplying it by a constant. Let's say I give you a 7-question quiz, and we write down how many questions you got right. And each question counts as, here what 7 is, like 14.2, I think. And we multiply your number correct by 14.2 to get our actual grades. We start out with the mean being the number of problems you got correct, and switching it now to your grade, is the mean going to change when multiplied by 14 something? You got 5 right. Now I'm switching it to your actual grade. Is your mean going to change? It's going to go from 5 right to like a grade of 70 something, right? If I multiply your median by a number, is it going to change? If I multiply your standard deviation by a number, is it going to change?
No.
So if let's say, we'll go with easy ones.
Is that like the data that we're using?
Yeah. Well, I'm trying to go easier than this. Let's say I'll talk about it theoretically here. Here the mean would be 5. My standard deviation is going to be something about 1, a little bit more than 1. So if I now switch these to grades, my standard deviation, which was a little bit greater than 1, if I switch those to grades, is my standard deviation still just going to be a little bit greater than 1?
No.
No, it's going to be a little bit greater than like 28 something. But the concept of what goes with this problem, I want to go ahead and write out. And I do want everybody to write this. So I'm adding or subtracting a constant, or I'm multiplying or dividing a constant. So measures of center work the same. That's like mean, median, so forth. Measures of spread work the same, just like standard deviation, IQR. And then we're also concerned with shape. So I've got this number line over here. I've got some distribution. I'm going to take everybody and give them 10 extra bonus points. So this started here. And now I give everybody 10 extra bonus points. Did my center change?
Is it possible for you to use a different color?
So I give everybody 10 extra points. My center was here. I give everybody 10 extra points. Did my center change?
Yes.
So my center, when I add subtract, is going to change. My spread, when I moved it from here to here, did what? So the distance of the spread, is that going to change?
No.
No. So when I add or subtract here, my spread stays the same. What happened to my shape when I moved it back and forth?
Stay the same.
Stayed the same. Alright, now when I multiply or divide, so this is like taking it on a scale like this. Is my center going to change?
Yes.
Yes. Mean always works exactly how you think it would, so it's always going to change. Did my spread change?
Yeah.
Yes, it was only this wide, now it's this wide. What happened to my shape?
Same.
It stays the same. So it's still going to have that triangle shape again. So this is generally what you could think of as this problem and be able to answer it really easily. And this box is the one that throws people off, and I think people are accidentally thinking that one for this problem and overthought it. At number 4. This is one that really concerns me, that it's this high, because this should be the easiest problem on the AP exam. It's the most basic of our class. I'm hoping people just looked at this problem quick and just accidentally picked the wrong thing. Now I'm going to draw something really quick on the board and then erase it, just to show you why I'm shorthanding all of this. So X is a random variable that has a normal distribution with a mean of 100, a standard deviation of 10. So 10 each direction. Sorry, I drew terribly. Everybody go with that? Mm-hmm. The only 2 problems that we are dealing with in this whole problem over there are 115 and 85. What's really important about those 2 numbers in this distribution?
The same distance away from the mean.
They're the same distance away from the mean. So instead of drawing this whole picture every single time, I'm going to shorthand it. I can write this as z-scores. If it's 85, what's 85 minus 100?
Negative 15.
Negative 15 divided by 10 gives me?
Negative 1.5.
As opposed to this one, which would be a z-score of what?
1.5.
So I'm just going to be using negative 1.5 and 1.5 based off of this instead of drawing that whole thing every time. So this first one, A, am I drawing a line at positive or negative 1.5?
Positive 1.5.
And then shading which way?
Upwards or to the right. Opposite to the left.
Should be left less than. What about in B? 1.5 or negative 1.5?
1.5.
Shading which way? What's different between A and B?
It includes the 1.5.
One says less than and one says less than or equal to. As far as this, does that make any difference to us? So those are actually equal, which means we can actually knock them out. C, negative or positive 1.5?
Negative.
Shade which way? D, it actually says you have both. And shade what?
In the middle.
And then E, where's my line?
Negative.
Now it says take this one and shade to the left of that, but then take the opposite. So you're actually shading to the right. And it wants to know which is the same as this one. Well, this one is starting at positive or negative and shading which way? So which one of those pictures has the same amount shaded as this one? And that's pretty much the most basic, that consists of pretty much everything we deal with this class. And you should, like I said, I'm hoping people just kind of did it quick and weren't thinking about it because I thought it was going to be an easy problem. But I need to make sure we all feel at least good about that.
Do you have percentages for like how much of the class missed?
Yes. This one, I had almost 50% of the people chose E. And I think it's because they just weren't looking at the 1 minus, I'm hoping. And about 35% of people got it right.
How about the hardest question? Was that, like, what was the success rate on that?
12.5. But that's pretty typical of some of them. First, especially, actually over break, I'm not surprised with some of these. Next problem is number 7. Alright, so I'm going to talk about more than just this problem. I'm going to talk about other things first. It says stratified random sampling. Stratified random sampling we often think of with which other random sampling? There's 4 of them, but which one is the most like stratified?
Clusters.
Alright, with both of them, we start by doing what? Putting the whole population what? We're going to put them into groups. How do I put them into groups with stratified?
Characteristics.
I want to put all the freshmen together. I want to put all the sophomores together. I want to put all the juniors together. I want to put all the seniors together. As opposed to cluster, I do what?
Representative of the population.
Representative of the entire population, which means they are similar between. Each group that I have would hopefully have freshmen, sophomores, juniors, and seniors in each group. The second thing that is different about them and important is how I do what?
Select.
How I select. How do I select for stratified?
You select a few from each group.
And now they should be proportional, whether it's the same size or not. It should be proportional to population or proportional to each group. But you're taking some from each, as opposed to cluster, I take what?
Select one group.
Entire group or groups. And this is definitely something you will see with that concept right there. So now just actually going through the problem, it is only talking about stratified. Is it important in stratified to have random sampling?
Yes.
Yes, it's always important to have the randomization in there. In stratified, is the population divided into groups that are similar?
Yes.
In stratified, are the strata based on facts that are known before the sample is selected? I know what grade you're in before I decide how I group you. Each individual unit in the population belongs to one and only one of the strata. That's one that I probably haven't emphasized enough. If you're in more than one group, then that means technically you can be chosen more than once, which messes up with everything with your probabilities. But so yes, you can only be in one group. And then E, if E was not a trigger to you, write this down somewhere. Most of you, I'm hoping, as soon as you see E, know exactly what that is talking about, which is what? That is the absolute definition of
Simple random sample.
simple random sample. There are not many things that I can say I pretty much guarantee they're going to be a multiple choice. The definition of simple random sample I pretty much guarantee is going to be somewhere in the multiple choice. So, is this the same thing as a stratified?
Nope.
No. So this is the one that does not apply, so your answer is B. And now, my last class went ahead while we were here and asked about the one other that I'm missing. What is my other sampling technique that we talked about that is not one of these 3? What do I do first with systematic?
Order them.
And then I choose
Random.
how?
every other by a certain like
Yeah.
number.
So these are the 4 main sampling techniques. Systematic shows up the least often for our class. Simple random sample is more ideal than the other 2 most of the time. But it's going to ask you more specific questions probably about stratified and cluster. At number 10, this should be your 15th problem. The distribution of diameters of a particular variety of oranges is approximately normal with a standard deviation of 0.3 inches. How does the diameter of an orange at the 67th percentile compare with the mean diameter? This is not that hard of a problem, but I get why people miss this one. Because they just don't know where to start. Let's start by this word. What's going to go there? Percentile always means shade. Somebody said okay. It's all the people, the way I always say it is all the people you did better than, all the people that are below you. So you always want to shade left. So what does it mean, very generally, to be in the 67th percentile?
You're better than 67.
You
did better than 67% of the people. So where should you be in relation to the mean?
Above it.
So there's no reason that you should answer A or B if you look at that and think about it. Even if you have no idea where to start. And if you'll notice, and especially the problems we've done so far, the hard ones, usually always in a hard problem, you can pick out a piece of it and be like, I have no idea where to start, but I understand what that piece means, and knock out 2 or 3 choices. So I need you to be able to understand that stuff as much as I do for you to understand each individual problem. Like I don't want you to get to a problem and panic and be like, I have no idea, let me circle a number or circle a letter. I need to at least get to the point where let me pick out a tiny piece, and if I can eliminate 1 or 2, I'll make my chances better. All right, so now we're actually going to go through this problem, and I don't know that everyone would have thought to do this, and I'm fine with that at this point, especially coming off the break. So 67%, which means I'm shading left. So this is 0.6700. If a problem says approximately normal, that means I know that I can what?
Go by the empirical rule.
Go by the empirical rule, or use Z, or use your yellow sheet. This is the last problem I'm going to make you do, and because of that, I want to actually do this one. So if everybody will get out your yellow sheet, so I want to review this while we're here. We have 2 types of numbers in a Z table. You have numbers on the outside, which are your what kind of values? Those are your Z's. What's here?
Yeah, the areas.
Area, or what's the other thing we can call them? Percentile probability. So is 0.6700 a Z or an area probability? Area. So I would be looking for 0.67 here. So go ahead and find the closest thing to 0.67 in here.
0.44.
And you filter it out, and so that gives you a Z of 0.44. And now I can't pull up my computer or my calculator on my screen 'cause it does this, but do you remember which button you push in the calculator to do the exact same thing?
Was it inverse?
It's inverse norm, and you could just type in 0.6700 there too, and it still gives you the
You press second distribution first.
yes, second distribution there, yes. Now, this is asking for how does it compare with the mean? So is my z what I'm asking for? If I said what is the definition of a z-score, what is it?
The formula,
No.
number of standard deviations away from the mean.
So this is telling me how many standard deviations I am away from the mean. So is that my answer? No. So one way I could look at this is I know that my z is 0.44. I don't know my x. I don't know my mu. But I know my sigma is 0.3. So what do I do with these?
Multiply.
Multiply them, which gives me 0.132. All I'm left with is the distance from the mean. If you got to here and didn't think about this, I understand that one standard deviation is 0.3 away. This is more than that. This is 2/3 of that. This is less than half of that. And we want less than half of that. Questions with this one? All right.